Hi, my name is Patrick Friedman, and I will be explaining computer clusters and how they are used today for our COSC 2425, Section 55420. A computer cluster is a set of loosely or tightly connected computers that work together so that in many respects they can be viewed as a single system. A computer is known as a node, and multiple nodes work together for their respective result. They can be used as space simulations, web servers, research, and many more. In 1997, a paper published by Gene Amadali of IBM formally invented the basis of cluster computing as a way of doing parallel work. It is now known as Amadali's law. It is a model for correlation between the expected speedup of parallelized implementations of an algorithm relative to the serial algorithm, assuming the problem size remains the same. So the more processors, the more nodes or computers, the faster you can do whatever you want to do. Clusters are popular due to the ease of deployment and availability. The components of a cluster are usually connected to each other through fast local area networks, or LAN, with each node or computer in a server running its own instance of an operating system. Computer clusters emerged as a result of convergence of a number of computing trends, including the availability of low-cost microprocessors, high-speed networks, and software for high-performance distributed computing. The three types of clusters are high-performance clusters, high-availability clusters, and load balancing clusters. High-performance computing are used for compilation-intensive applications, rather than handling I/O-oriented applications such as a web server or databases. Examples of high-performance computing, or HPCs, can include the computational simulations of vehicle crashes and weather. Very tightly coupled computer clusters are designed for work similar to supercomputing, or for lack of a better term, a supercomputer. High availability clusters are used to improve the availability of the cluster approach. In high availability clusters, redundant nodes are used which take over in case of component failure. High availability clusters are often used for critical databases, files shared on a network, and business applications. Load balancing clusters, as the name suggests, are the cluster configurations where the computational workload is shared between the nodes for a better overall performance. The way clustering works. The components of a cluster are usually connected to each other, with each node running its own instance of an operating system. Computer clusters have each node set to perform the same task and are controlled and produced by software. The benefits of computer clustering is absolute scalability, which means it is possible to create a large cluster that beats the power of even the largest standalone machines. A cluster can have dozens of multi-processor machines. There's additional scalability. A cluster is configured in such a way that it is possible to add new systems to the cluster in small increments. Clusters have the ability to add systems horizontally. This means that more computers may be added to the cluster to improve its performance, redundancy, and fault tolerance, or the ability for a system to continue working with the malfunction of a node or a power surge. High availability. As we know that each node in a cluster is a standalone computer, the failure of one node does not mean a loss of service. A single node can be taken down for maintenance while the rest of the clusters take on the load of that individual node. And preferable price per performance. Clusters are usually set up to improve performance and availability over single computers, while typically being much more cost effective than single computers of comparable speed and availability. HPC is expected to move in exascale capacity by 2020, developing computing capacities 50 times greater than today's most advanced supercomputers. High performance computing, or HPC, is a broad term that in essence represents compute intensive applications that need acceleration. Users of application acceleration systems range from medical imaging, financial trading, oil and gas exploration, to bioscience data, warehousing, data security, and many more. In the information age, the need for acceleration of data processing is growing exponentially, and the markets deploying HPC for their applications are growing every day. The HPC expansion is being fueled by the coprocessor, which is a fundamental piece of the future of HPC. I have facts for the history of HPCs and just random facts while I go over my sources. The first commercial clustering product was ArcNet, developed by Datapoint in 1997. Digital Equipment Corporation released their VAX clusters products in 1984 for the VAX VMX operating system. The ArcNet and VAX clusters products not only support parallel computing, but also shared files and peripheral devices. The idea was to provide the advantages of parallel processing while maintaining data and reliability and uniqueness.